Divide and simplify. We have the square root of 40 divided by the square root of 14. And when I have two radicals that are being divided, I always look to see if they have any factors in common. And in this case, they do. So rather than make the problem larger by multiplying the numerator and denominator by the square root of 14 and then have to factor it down, I'm going to go ahead and simplify first by writing this as a single radical. So it becomes the square root of 40 over 14, which can be simplified by dividing a 2 out of the top and the bottom. It becomes the square root of 20 over 7. Now this doesn't simplify any further, so I'll have to rationalize this denominator by splitting it back up again into the square root of 20 divided by the square root of 7. And to rationalize my denominator, since it's a square root, then I need a smallest perfect square that I can find. Well, I would just multiply the square root of 7 by itself, square root of 7. And I need to do that in the numerator and denominator. Now, once again, instead of multiplying 20 times 7 and getting a larger number, I know that 20 already has a perfect square factor in it. So I'll go ahead and write 20 as 4 times 5, and then leave the times 7 in there as well. And then my denominator, square root of 7 times square root of 7, is just 7. So now I can see that my square root of 4 can actually come out to be a 2, because the square root of 4 is 2, and then what's left under the radical is the 5 and the 7, which I need to put back together as 35. So I have 2 square root of 35 over 7.